To end off this section on linear equations, let's have a look at simultaneous linear equations. So if we have a look at one of the equations that we've been given, we see that we've got not one variable this time, but two different variables. And a lot of people are uncertain about why they're doing simultaneous equations. They think it's just another thing that they've got to learn. But if we understand what the purpose is behind simultaneous equations, it makes it much more meaningful. So if we think to a Cartesian plane, and if we were drawing this Cartesian plane in order to plot some linear graphs, in other words straight line graphs, we would first of all need to get our equations for our straight line graphs into the general form, which is y equals mx plus c, where m is speaking about the gradient or the slope of the line, and c is speaking about the cut on the y-axis. So where's the line cutting this axis? And here's my x-axis. So hypothetically, let's just imagine any two straight line graphs on this Cartesian plane. I'm just drawing randomly any two. Okay, so unless those two straight line graphs are parallel to each other, which in this case they're definitely not, in other words, but rather they actually look as if they're almost perpendicular. But regardless of that, if they're not parallel to each other, then somewhere on the Cartesian plane they're going to cut each other, they're going to intersect. And that point of intersection, which will be made up of an x coordinate and a y coordinate, is actually what we're working out when we work out simultaneous equations. So this equation could be rewritten, making y the subject of the formula, which we did in the previous episode, with literal equations, making one of the variables the subject of the formula. So I could write this in the form of y equals mx plus c. I could also write this equation in the form of y equals mx plus c. In other words, they do both represent straight line graphs. And then it would be quite a lot of work to first of all manipulate the formulae, then to actually plot the graphs, and then read off the x coordinate and the y coordinate, in other words, to find out what that coordinate of that intersecting point is. But the beauty of it is that with simultaneous equations, I can do the whole thing algebraically without drawing the graph at all and find that point of intersection, which I think is quite amazing. So if you understand why we're doing simultaneous equations, it makes it a lot less tedious. So in this episode, we're going to look at the first method for finding the answers for x and y, and that's called the elimination method. So there are two methods, the elimination method and the substitution method. The way to decide which one you're going to use is first of all to look at your x terms in both equations and your y terms in both equations. And if you have a situation like this where you've got a 3x and a 3x which are exactly the same, then I would suggest you use the elimination method, because what we're going to do is exactly what the name says. We're going to eliminate one of the variables by doing something with these two equations. So remember, because it's called simultaneous equations, we have to work with the two equations simultaneously, in other words, at the same time. So to avoid confusion, I always suggest that you number your equations, and then as you're working, you keep telling the reader what you're actually doing. And it also helps you, because if you get to a certain point and you think, oh, now where did I do that? It's right there in front of you. You've actually set it out in such a way that you can read back and see what's going on. So because this is 3x and that's 3x, if I said 3x minus 3x, I'd get 0, which means that I would have eliminated my x's. So if I minus the x terms, I have to minus all the terms. In other words, I'm going to say equation 1 minus equation 2. So 3x minus 3x gives me 0, which means it disappears. Then be careful here because of this negative sign. You're saying 2y minus negative 3y. 2y minus negative 3y, which actually means 2y plus 3y, which is going to give me 5y. and then 60 minus 45 is going to give me 15. So just in knowing what to do with those two, that looks like really complicated, a whole lot of stuff going on there. Just by making the correct decision, we've brought it right down to this point, where to get y on its own, I need to divide by 5, divide by 5. So therefore y is going to be 15 divided by 5 is 3. Don't stop there, because remember we're trying to find an ordered pair which is made up of an x coordinate and a y coordinate. I've got the y coordinate. So now I'm going to substitute y equal to 3 into one of my original equations, and it doesn't matter which one you substitute it into, you will get the same answer. So I'm going to choose number 2. It really makes no difference. So what I do now is I write down equation number 2 exactly as it is, except where there's a y value, I'm now going to write 3. So I've got 3x minus 3 times the y value of 3 equals 45. I'm going to do two things in one step now. The only x value I've got here is this one, so I'm going to leave 3x on this side. I've got 45 on that side, it's not changing sides. This is giving me negative 9, and when I take it across, it's going to become positive 9. So 3x is equal to 45 plus 9 is 54. And then I need to divide by 3, divide by 3. So x is equal to, and this is where most people will whip out their calculators, but I find if you keep your brain moving and keep it working with mental maths, then you actually save time. It's quicker than trying to punch the keys of the calculator. So 3 into 5 goes once, remainder 2, and 3 into 24 goes 8. So my x value is 18, and my y value is 3, and so then I need to end off by showing what my ordered pair is, and remember, always write down your x value first, followed by your y value. So if I decided to draw a Cartesian plane, write both of these in general form of y equals mx plus c, and then plot these two graphs on the Cartesian plane, if I did it accurately and then read off the point of intersection, they would be intersecting at the point 18, 3. Please watch out for the next. I'm going to be doing 3 more episodes on simultaneous equations because there's so much to cover, and I'm going to end off in part 4 of this episode with a very nice challenge that will get you thinking, and if you can work through that one, then you should be able to work through any simultaneous equation in an assessment. So please look out for the next episodes, and the best way to do that is to click the subscribe button.